Welcome. Jirra jirtu hordoftoonni KOOKEEF-TUBE har'a boqonnaa lammaffaa paartii sadaffaa qabannee dhufneerra linear regression kan jedhu paartii tokkoffaaf lammaffaa already ilaallee turre. Har'a immoo paartii sadaffaa statistical properties of least square estimators and the properties of OLS estimator kan jedhu waliin kan ilaallu ta'a. Kanaaf part 1 part 2 special estimation method kan jedhu ilaallee turre. Har'a immoo part 3 statistical property of least square estimator and the property of OLS estimator kan jedhu waliin kan ilaallu ta'a jechuudha. Kanaaf akka waa irraa qayyabachaa jirtan abdiin qaba. So hopefully understand something at the end of this theory as well. So the idea or optimum property that an OLS estimates possessed by maybe summarized by a well-known theorem known as Gauss-Markov theorem. So statement of theorem gives the assumption of the classical linear regression model. The OLS estimators in the class of linear and the unbiased estimators have the minimum variance. This means OLS estimators are blue. So as a Gauss-Markov theorem kan jenneni torba ture walumatti kurnan immoo paartii tokkoffaarratti kanneen ilaallisanii jechuudha. What are the 10 assumption of Gauss-Markov theorem kan jenne jechuudha. Kanaaf with perspective of Gauss-Markov theorem propertiin OLS estimatorii maal fakkaata kan jedhudha jechuudha. Kanas itti ilaalamu qabu. So statement of theorem given the assumption of the classical linear regression model, the OLS estimators in the class of linear and the unbiased estimator have a minimum variance. This was one statement of Gauss-Markov theorem. Therefore, OLS estimator are blue is that show that the minimum variance. The minimum variance. So according to this theorem, under the basic assumption of the classical linear regression model, the least square estimator are linear, unbiased, and have a minimum variance. So according to our Gauss-Markov assumption of classical linear regression model, the least square estimator are linear ta'uu qaba, lammaffaa immoo unbiased ta'uu qaba, inni sadaffaa immoo have a minimum variance ta'uu qaba jechuudha. So these mean are best of all linear unbiased estimators, all unbiased estimators jechuudha. So sometimes the theorem referred to as blue theorem. This means the best linear unbiased estimator, and the estimator is called blue. Kanaaf amma this theorem blue jechuun B indicates best, L indicate immoo linear jechuudha, U immoo unbiased estimator jechuudha. Kanaaf according to Gauss-Markov theorem this OLS is blue jechuudha dandeenya. But blue jechuudhaaf garuu or an estimator is said to be blue if እንደሆነልህ criteria kanneen yoo guutee tokkoffaa linear yoo ta'e, linear gaafa jenne a linear function of random variable such as dependent variable y is equal to x plus b formula akkasii qabaachuu qabaadha. Lammaffaa immoo unbiased gaafa jennu the average or expected value is equal to the true population parameter. So unbiased, its average or expected value is equal to true population parameter ta'uu qabaadha. Unbiased jechuun isa kana agarsiisa. Minimum variance gaafa jennu immoo it has a minimum variance in a class of linear and unbiased estimator. So unbiased estimator with the least variance is known as efficient estimator. Karaa biraatiin minimum variance or efficient estimator variance jechuu ni dandeenya jechuudha. OLS dha. Kanaaf OLS say to be blue if እንደሆነልህ having a minimum variance. So according to Gauss-Markov theorem, the OLS estimator possess all the blue properties jechuudha. Blue properties. So let us prove this property one by one. Amma isaannen kanneen prove gochuuf yaallachuu yookaan mirkaneessuuf yaallachuu. So የመጀመሪያው እንግዲህ linear ብለናል ወይም ደግሞ the OLS must be linear jennera. Kanaaf linear gaafa jennu maal jechuu keenya. So how we can prove whether the OLS estimator is linear. So the proposition alpha hat and the beta are linear in y jechuudha karaa biraatiin. Kanaaf linearity gaafa jennu for beta hat, so alpha and the beta are what? Linear in y jechuu barbaadete jechuudha. So from 2.1 from the previous 2.17 of OL estimator of beta is given by summation of xi yi over summation of xi square akka ta'e fi summation of xi into y minus y hat over summation of xi akka ta'e laallee turre faayilii isa kana jechuun immoo karaa biraatiin summation of xi times 1 minus summation of y hat summation of xi over summation of xi square akka ta'e fi but here summation of xi jechuun x minus x bar, which is equivalent to x minus nxi if our number of observation n gaafate nxi jenne akka laalleeti kanaaf nxi minus nxi will be at 0. Therefore beta is simply summation of xi y over summation of xi. Now let's xi over summation of xi is ki jennuni where I start from 1 to up to n. So b hat equivalent to summation of ki y. Therefore beta hat equivalent to k1 y1 is equal to k2 y2 plus k3 y3 is equal to up to kn yn jechuun ni dandeenya jechuudha. Therefore gaafa by is equal to k1 y1 k2 y2 gaafa jennu powering keenya asitti y1 in tokko y2 is tokko up to yn keenya tokko ta'a jechuudha. Kanaaf bifa kanaan kenname mx plus b yookaan immoo equation with one power kan ta'e yoo ta'e immoo linear akka ta'e beektu sila ta'ee fi beta is linear in y jechuu dandeenya jechuudha. Kanaaf linearity gaafa jennu bifa kanaan ibsamuu ni danda'a jechuudha. Unbiasedness proof alpha hat and the beta hat are unbiased estimator for the true parameter of alpha and the beta. Asin dura jenneerra alpha hat and the beta hat jenneeti kan estimate goonu maaliifi alpha hat and the beta hattiin determine kan godhaman from sample data waan ta'eefi waa'ee population data yookaan immoo true alpha and the beta determine gochuu hin danda'an approximately itti dhiyaatu malee exactly alpha and the beta determine gochuu akka hin dandeenya asin dura ilaalleerra. Kanaaf alpha hat and the beta hat are estimator value jechuudha. So from statistics goes numerical that if theta is an estimator of theta, then expected value of theta minus theta equivalent to the amount of bias. And if theta is unbiased estimator of theta, then the bias becomes 0. Unbiased is bias in 0 comes 0. Therefore, the expected value of theta minus theta multiplied to 0 bias in 0. So in our case, alpha hat and the beta are estimator of the true parameters alpha and the beta. To show that they are unbiased estimators of the respective parameter means to prove that expected value of beta hat is equivalent to beta. Again, expected value of alpha equivalent to alpha hat is equal to alpha ta. Kanaaf inni kun maal agarsiisa? They are unbiased or there is no bias between alpha hat and the alpha as well as beta hat and the beta. Kan jedhu agarsiisa jechuudha. Okay, proof that beta hat is unbiased. This means that the expected value of alpha or beta hat is equivalent to beta. So we know that beta hat is summation of k times yi equivalent to summation of ki into alpha plus beta xi plus ui. This ui immoo maanni error term jenneerra sin dura. Therefore expected value of error term immoo 0 akka ta'e sin dura laallee turre. Kanaaf now kana gaafa distribute gootan alpha into summation of xi plus beta into summation of xi plus summation of ki ui. So that summation of ki equivalent to 0 and the summation of ki xi is equal to again 1. Therefore summation of ki equivalent to summation of xi over xi square jenneerra. Isa kana gaafa distribute goonu bifa kanaan akka ibsamuu fi if n number of observation kan qabaannu yoo ta'e immoo n y's of xi minus n y's of xi over summation of xi inni gubbaa kun 0 sila ta'uu fi now it becomes 0 ta'a. Therefore summation of ki is equal to 0. This indicates there is no bias between beta hat and the beta kan jedhu agarsiisaa jechuudha karaa biraatiin. So suma kana fakkeenyaaf ki is if ki is a constant number so times xi bifa kanaan laboratory extend gochuu ni dandeenya. So at the end of the day summation of ki xi equivalent to 1 argachuu dandenya. So beta equivalent to beta plus summation of ki ui equivalent to beta hat minus beta. So this is the population parameter jechuudha. So this is called summation of ki ui jedha. So at the end of the day, since ki is fixed on constant number sila ta'eefi expected value of beta hat is equal to beta. That means the expected value of the error term 0 da inni irra. Therefore beta hat is unbiased estimate of beta. So isuma sana reefu sana babal'isa deemaa jira. So you have to know this one. Again, proof alpha hat is unbiased unbiased. This means that the expected value of alpha hat is equal to alpha. Kan jedhu proof godhaadha. Inni kunis akkuma reefu sana almost tokkuma. Garaagarummaa akkasuma waan qabanii miti. Kanaafi gabaabumatti unbiased gaafa jennu alpha jidduutti biasiin hin jiru. Ergaa jedhu dabarsuu barbaadeeti. This mathematical term akkasumara waan barbaachisu miti osoo beekame gaariidha. Garuu the main aim of OLS parameter is unbiased gaafa jennu the bias between alpha and the alpha is almost zero jechuudha. So in the minimum variance of alpha hat and the beta hat. Now we have to establish that out of the class of the linear and the unbiased estimator of alpha and the beta, alpha hat and the beta hat possess smallest sampling variance. For this, we shall first obtain a variance of alpha hat and the beta hat, then establish that each has a minimum variance in comparison of the variance of the other linear unbiased estimators obtained by any other econometric model than OLS. Kanaafi minimum variance of alpha and the beta gaafa jennu there is no extended variation of data of the sample variance jechuudha. Kanaaf minimum variance qabu jechuun variation of the data become very minimum jechuudha in both cases. Kanaafi minimum variance alpha and the beta qabaachuun immoo probably alpha fi beta sample estimator ida isaanin kunniin population estimator alpha and beta kan jennu sana wajjin carraa equivalent ta'uu qabu jechuudha garaagaraatiin. So here the variance of beta equivalent to variance of population to summation of individual item. This means the summation of error term over n minus 2 into summation of xi square. Here the variance of alpha also alpha square is equal to variance of population meaning summation of xi over n times summation of xi, which given by summation of the error term into xi or individual item over n into n minus 2 summation of xi. Here the error term can be computed as isa kanan bifa kanan akka determine goonu error term chapter jalqaba irratti chapter 2 part 1 irratti ilaallee turre. So now you have to substitute this term in place of this. Substitute gochuu ni dandeenya jechuudha. So dear student, don't worry about the derivation of this expression. We will perform the derivation in our subsequent topic. This is the concept of mathematics. You know that the secondary derivation concept mathematics or calculus is an beeku nama tokko akka barbaachisu laallee irraa derivation hojjechuudhaaf isa sana isinitti himuuf barbaadeeti jechuudha. So the variance of the random variable ui, you may observe that the variance of OLS estimator involves the population variance, which is the population variance of the random disturbance term. But it is difficult to obtain the population data of the disturbance term because of the technical and economical reason. Hence, it is difficult to compute the variance of the population. Variance of the population. This implies that the variance of OLS estimators are also difficult to compute, but we can compute the variance if we take the unbiased estimator of population variance and the expected value of the population variance. Therefore, this expected population variance is equivalent to summation of the error term over n minus 2, where n is the number of sample or number of data. So here, this term become the summation of error term over n minus 2 is unbiased estimator of the true variance of the error term of the population variance. So the conclusion that we can derive from the above proof is that if we can substitute this in terms of for this error term in the variance expression of alpha hat and the beta hat, since the expected value of the so here simply the expected value of the variance of expected estimators equivalent to what? That of the population variance. Hence the formula of variance of this and this becomes almost to this, so variance of beta equivalent to this parameter to summation of xi kana again variance of alpha equivalent to like this, so summation of xi over n times summation of xi square, or it can be equivalent with this error term jimo kana mulqixxeessu dandenya. Error term jechuun akkuma isin dura ilaalle kanaan bakka bu'uu waan danda'uuf jechuudha. Kanaan bakka bu'uu waan danda'uuf. So in terms of statistical test of significance of the OLS estimators or first order test kan jedhu ilaalla jechuudha. Statistical test of significance of OLS estimator, amma OLS estimator idhaan parameetroota alfaa fi beetaa estimate gochuudhaaf kan inni fayyadu. Statistical testing yookaan significance isaa moo maal fakkaata? So significance isaa test godhamuu qabaachuudha by using different testing scenarios. So after the estimation of the parameter and the determination of the least square regression line, we need to know how good is the fit of this line to the sample observation of y and x. Graph y is equal to mx plus b kan jedhu asin dura by using dependent and independent variable plot gochaa turre jechuudha. Kanaafi how that graph is good fit, so goodness of fit isaa test kan itti goonudha jechuudha. Goodness of fit test. So we need to measure the dispersion of the observation around the regression line. This knowledge is essential because it's closer the observation of line. So the better the goodness of fit, this means the better the explanation of the variation of y by the change in the explanatory variable x. So gaafa variance yookaan immoo error termiin keenya gadi bu'aa deeme almost data nuti collect goone completely to the line gaafa oolan, we say that OLS estimator technique is statistically significance or goodness of fit test feel godhee jechuu dandeenya jechuudha. So the coefficients of determination of the square of the correlation coefficient are square. This test is used for judging the explanatory power of the independent variables. The standard error test of the estimators. This test is used for judging the statistical reliability of the estimator of the regression coefficient. Kanaafi R square value keenya gahee guddaa taphata jechuudha. Graafii keenya y is equal to mx b kan jedhu linear regression graafiin y versus x dhaan gaafa plot goone daataan nuti collect goone in reality laayinii sanarraa ooluu qabu, garuu laayinii sanarratti hin oolan. Hamma tokko laayinii sana ol positively correlated yookaan negatively correlated ta'uu qabu jenneera. Kanaaf hamma tokko gara laayinii sanatti akka dhiyaatan gochuudha jechuudha. Goodness of fit test gaafa jennu. Kanaafi R square value keenya gara tokkotti dhiyaachaa gaafa deemu that is almost a good correlation jechuu dandeenya jechuudha. So R square shows that the percentage of the total variation of dependent variable that can be explained by the change in explanatory variable included in the model. So to elaborate this, let's draw the horizontal line corresponding to the mean value of the dependent variable y. By fitting the line y bar or y hat equivalent to alpha hat naught plus beta hat x, we try to obtain the explanation of the variation of the dependent variable y produced by the change of the explanatory variable x. So akkuma reef dubbachuuf yaalletti fakkeenyaaf graafiin keenya y x versus y or y versus x bifa kanaan plot gaafa goonu, amma now this line is equivalent to line of regression line. Kanaaf in reality daataan keenya graafii kanaa gara gadii yookaan immoo graafii kanaa karaa olii daataa hedduutu argamuu danda'a jechuudha. Daataan keenya akkuma jiruuni graafii kanarratti hin oolu. Kanaaf estimator kan jennu jechuudha. Estimation of alpha and beta hat kan jechaa jirruu fi kanaaf. Now this graph equivalent to gamma hat is equal to alpha hat naught plus beta 1x. So it is y. The concept of this one is y intercept. This one is slope or coefficient. So now goodness of fit testing keenya kanutti himu daataan keenya hammam gara graafii kanatti dhiyaatee argamaa. So isa kana ammatti kan statistically check kan goonu yookaan significance isaa estimate kan goonu jechuudha. So here error term is equal to yi minus y hat, the deviation of the observation y from the regression line jechuudha. Again xi is karaa biraatiin xi x minus x bar jechuu ni dandeenya, the deviation of observation from the regression line jechuudha karaa biraatiin. So now we may write the observed y as a sum of the predicted value y hat and the residual term or error term like this. Formula kanaan akka ibsinu asin durallee laallee turre jechuudha. Amma kaayyoon keenya inni guddaan residual term yookaan error term kana minimize gochuudha jechuudha. So we can have the above equation, but the deviation from the derivation y equivalent to y hat plus e. By squaring both sides, we get this equation. So summation of y square is equal to summation of y square plus error term or okay. Isa kana square gootanii binomialiidhaan gaafa dirristan summation of y square plus e square plus twice of y e ta'a. y ta'a. Summation into gara keessatti waan seentuuf formulaan kun bifa kanaan distribute ta'a jechuudha. Bifa kanaan distribute ta'a. Then after that summation of y times error term equivalent to bifa kanaan ta'uu danda'a. Maaliif error term can be expressed by this. Now then error term can be this one. So at the end of the day, summation of error term immoo 0 fi expected value of error term immoo 0 akka ta'e immoo assumption keenya irraa ni qabna. Therefore summation of y times error term is equal to 0. Therefore the total variation equivalent to explained variation plus unexplained variation ta'a jechuudha. This unexplained variation kan amma kunuunsa of fit testing gara 0 tti fiduudha jechuudha kaayyoon isaanii guddaan. So here the total summation of square TSS equivalent to explained sum of square ESS plus residual sum of square RSS. Therefore, mathematically the explained variation as a percentage of the total variation is explained as ESS over TSS is equal to summation of y hat square over summation of y square. So now we have y is equal to beta times x, squaring both sides again we get this one. Now you have to substitute this value into this b square summation of xi over y square. Now again you have to have what determine b or beta hat. Simply beta hat asirratti determine gochuu ni dandeenya. So beta hat is equal to summation of xi y over summation of xi jechuu ni dandeenya jechuudha. So comparing with the formula of correlation coefficient or covariance aspect. So the covariance of x and the y with error term of standard deviation x, standard deviation of x 1 square. So become like this. So then at the end of the day r square is expressed by this formula. Kanaaf r square keenya bifa kanaan argachuu dandeenya. Sana booda gatiin r square keenya maal ta'a kan jedhu laaluudha jechuudha. If r square is almost approach to 1 gara tokkotti kan dhiyaachaa deemu ta'e jechuun termiin kun 0 kan ta'u ta'e our graph is linear or good fitness qabachuudha yookaan immoo tokkorraa fagaachaa gaafa deemu immoo deviationiin yookaan residual termiin isaa baay'ataa yookaan dabalaa jira jechuudha kanaan ibsama. So interpretation isaa gaafa fakkeenyaaf ilaaltan asirratti r squaring keenya 0.9 jechuun this means that the regression line gives a good fit to observed data since the line is 90% of the total variation of y around their mean. The remaining 10% of the total variation y is unaccounted for the regression line less attributed factor of disturbance or error term jenna. Kanaaf 0.9 gaafa jennu almost 90% good jennaan 0.95 gaafa jennu 95% jenna 0.99 gaafa ta'u almost gara tokkotti dhiyaataa jira waan ta'eef goodness of fit testing keenya almost bareeda ta'aa deemaa jechuudha. Therefore testing significance value of OLS parameter gaafa jennu how this r square is approach to the reality graph jechuudha. So inni lamaffaa testing the significance of OLS parameter. So to test the significance of OLS parameter estimation, we need to the following: one, variance of the parameter estimator, unbiased estimator of the population variance, and the assumption of normality of the distribution error term. So isaanin sadeen significance of OLS parameter test gochuuf criteria yookaan parameteroota sadeen kana beekuu qabna. Tokkoffaa variance of the parameter estimator beekuu qabna, unbiased estimator of population variance beekuu qabna, assumption normality of distribution of the error term qabaachuu qabna jechuudha. So we have already derived that variance of beta is equal to the error term divided for x square variation of or variance of alpha hat is equal to the error term times summation of xi over n times summation of x square. Again, this can be expressed in this scenario RSS over n2 minus 2. Okay, as in derive a formula can actually. So now we have already assumed that the error term is normally distributed with 0 mean and the variance which is equal to population variance. This means that the error term is approximately normally distributed with 0 mean as well as population variance. So similarly, we also prove that y is approximately normally distributed with alpha plus beta x as a mean and this standard or standard deviation of population or variance of population. So now we want to show the following here. Beta is normally distributed and alpha is normally distributed with this parameter. So the only estimate of alpha hat and the beta hat are obtained from the sample observation on y and k. Since sampling error are inevitable in all estimate here on the error in enough one inevitable. Error is what? Inevitable. So it's necessary to apply the test of significance in order to measure the size of the error. Error in enough one error gutuman gututti hambisuun hin dandeenyu waan ta'eef error sana hammami kan jedhu kan minimize gochuu dandeenya. Gaafa minimize goonu immoo error san quantify gochuu danda'u qabna jechuudha. So now it is the technique by which that error term can be what quantified or estimated. Kan jedhu validation isaa check itti goonudha. Qofa metodoota qabnu keessaa standard error test, student test, and confidence interval test kan jedhamantu jira. All of this testing procedure reach on the same conclusion. So we will see one by one, but their aim or the conclusion is almost similar. So standard error test gaafa jennu this test help to decide whether the estimate alpha hat and beta are significantly different from zero. Kanaaf gabaabumatti standard error testing kan nu fayyadu alpha hat and beta hat or estimation of alpha hat and beta hat are significantly different from zero akka ta'an beekuuf nu fayyadu jechuudha. So here whether the sample from which they have been estimated might have come from the population whose true parameter are 0. This means alpha given 0 as again beta is equal to 0. So formally we test the null hypothesis. So the null hypothesis states that beta is equal to 0 against the alternative hypothesis, which means that beta is quite different. Kanaaf statistics irratti akka laallutti yeroo hundaa null hypothesis keenya equivalent to 0 jedhee ka'a. Alternative hypothesis keenya immoo or H1 or HN keenya immoo is different from 0 jedha. Kanaaf jalqaba hypothesis keenya test gochuun keenya dura hypothesis keenya list gochuun baay'ee barbaachisaadha jechuudha. Baay'ee barbaachisaadha. So standard error test may be outlined as follows. So the first compute standard error of the parameters. So standard error of beta is equal to radical of variance. Standard error is equal to or standard deviation is equal to radical of variance akka ta'e beektu. Compute goona. Now second compare standard error with the numerical value of alpha and beta. Now finally you have to decision rule. If standard error of beta hat is greater than half of beta hat, accept the null hypothesis and reject the alternative hypothesis. We conclude that beta is statistically insignificant. Pero null hypothesis in Kenya accept the alternative hypothesis in Kenya reject the beta I. You can beta hat I statistically insignificant. Haala kanaan immoo if standard error of beta I is less than half of beta hat kan ta'e yoo ta'e fi null hypothesis keenya reject ta'e alternative hypothesis keenya immoo accept ta'e maal jenna beta hat or beta I hat is statistically significant jenna jechuudha. Kanaaf this one is a decision rule keenya jechuudha. Decision rule keenya jechuudha. So isuma kana jechuudha kan mareef dubbachaa jiru. So acceptance or rejection of the null hypothesis has definite economic meaning. Namely, acceptance of the null hypothesis means that population parameter is equal to 0. The slope of the parameter is what? 0. This implies that explanatory variable to which this estimate relates does not in fact influence the dependent variable y and should not be included in the function since the conducted test provided evidence that change in x leave y unaffected. In other words, acceptance of null hypothesis implies that the relationship between y and x is in fact y is equal to alpha plus 0 times x which is equal to alpha. Therefore, there is no relationship between x and y. Kanaaf dependent variable fi independent variable keenya hariiroo humaatu hin qabanii ergaa jedhu dabarsa jechuudha gaafa null hypothesis keenya accept goonu jechuudha. Kanaaf null hypothesis accept ta'e jechuun dependent and independent variable keenya hariiroo humaatu hin qabanii jechuudha. Inni kun immoo maal agarsiisa? The test is what or beta hat is what estimation of parameter of beta hat is what insignificant ta'uu isaa nutti hima jechuudha. Asitti example nu kennameera fakkeenyaaf sample size keenya 30 yoo ta'e fi sample demand or quantity keenya the quantity is given by 120 plus 0.6 p plus error term osoo ta'e fi standard error keenya immoo 1.7 nu kennameera. Kanaaf jedha test the significance of the slope parameter at 5 degree of level of significance. Alpha value keenya duwwaa tuqaa 5 nu kennameera. Kanaaf test the significance of beta hat. Amma beta hat keenya estimate goone beta hat nu kenname sun immoo already asitti kennameera beta hat. So beta hat value keenya significant immoo insignificant kan jedhu check goona jechuudha. Kanaaf naa asirratti akka argitanitti beta waan keenya nu kennameera slope ni 0.6 kanaaf haafii isaa fudhanna. Haafii isaa gaafa fudhattan 0.3 ta'a jechuudha. 0.3 ta'a. Kanaaf standard error term keenya 0.05 beta half of beta immoo beta 1 or beta n immoo 0.3 dha. Kanaaf amma isaan lama compare gochuutiin null hypothesis keenya reject yookaan accept goona jechuudha. So this implies standard error is beta is less than 1 over 2 of beta I kana jechuun 0.025 irra xiqqaa 0.3 waan ta'eef this implication that beta is statistically significant at 5 degree level of significance. Kanaaf sila standard error of beta is less than half of beta waan ta'eef statistically significant dha jechuudha. Kana jechuun null hypothesis keenya reject ta'e alternative hypothesis keenya maal ta'eera accept ta'eera jechuudha. So standard error test is approximate test which is approximated from z test and the t test and implies two tail test conducted at 5 degree of level of significance. Kanaaf one tail test and the two tail test kan jedhu chi-square distribution da hypothesis testing irratti ilaalleerra waan ta'eef maal jechuudha kan jedhu deebitanii statistics ilaaluu dandeessu. Viidiyoo isaa already asuma irratti hojjetameera waan ta'eef. Inni lammaffaa student t test ila. Inni kunis sanuma aiming keenya dhumarratti wanni argannu hariiroo x fi y jidduu jiru determine gochuu fi estimator or betaan keenya it is what significance damo significance miti kan jedhu beeku waan biraa miti. Like the standard error test, this test is also important to test the significance of the parameter. So from your statistics any variable x can be transformed into using the general formula. So t test ga fayyadamu formula keenya t is equal to x minus mu over standard error. Now n minus 1 is simply degree of freedom. Maalif degree of freedom determine gochuun standard deviation determine gochuu keessatti waan nu fayyadu jechuudha. So inni kun population mean jechuudha. Inni kun immoo standard deviation jechuudha. So standard deviation is equal to radical of summation of x minus x bar square over n minus 1 akka ta'ee fi n keenya immoo number of sample yookaan sample taken akka ta'e ni beekna waan ta'eef by this scenario student test dhaan parameter keenya significance damo insignificant jenne beekuu ni dandeenya jechuudha. We can derive the t value of OL estimator like so t beta hat is equal to beta hat minus b naught over standard error of b. Again alpha or alpha hat is equal to alpha hat minus alpha over standard error with n minus k degree of freedom jira. Standard error k is the number of parameters in the model. So since we have two parameters, since in the simple linear regression with intercept different from 0, our degree of freedom is n minus 2. Always degree of freedom is what? N minus 2. And the standard, no, our null hypothesis is always stated as h is equal to b, I is equal to 0. And the alternative hypothesis b, I is equal to different from 0. No? The slope parameter. So, para alpha tiris gafa state gonu, alpha is equal to 0. So, null hypothesis, alternative hypothesis anymore. Alpha is different from 0. Now we can check or we can test the significance by using student t-test so as to get a decision rule at the end of the test. For example, to undertake the above test for the following step, the first step is simply compute t, which is called computed t value, and state the null hypothesis as well as alternative hypothesis. So T Kenya, T calculating Kenya, simply B half over standard error of B, standard error of B under the given degree of freedom. Any lamafa choose the level of significance. Alpha value Kenya determine what should and do come. So the level of significance is the probability of making a wrong decision. This means the probability of rejecting hypothesis when it is actually true, or the probability of committing type 1 error. Kanaf error lama commit akka gonu statistics irratti ilaalleerra, type 1 error and type 2 error. Yes, type 1 error kan jennu probability of accepting the wrong decision jechuudha. Probability of accepting wrong decision. Yes, kana jechuuni carraan true hypothesis reject itti ta'utu jira jechuudha. The probability of rejecting the hypothesis when it's true. Yeroo hypothesis keenya true ta'e carraa reject ta'utu type 1 error jennaan. True hypothesis reject gochuun type 1 error jedhama. False hypothesis accept gochuun immoo type 2 error jedhama jechuudha. Look, true hypothesis reject gochuun type 1 error ta'a. True hypothesis reject gochuun type 1 ta'a. False hypothesis accept gochuun immoo type 2 error ta'a jechuudha. So in econometric research, yeroo baay'ee choose 5% level of significance or 1% level of significance. This means that in making our decision, we allow or tolerate 5 times of 100 be wrong or reject the hypothesis when it is actually true. So 95% the probability of what accepting the true hypothesis, and the 5% the probability of rejecting the true hypothesis. 5% level of significance kan jennu jechuudha. Fakkeenyaaf type 1 error kan jennu false positive. False positive type 1 error jennaan. Fakkeenyaaf you are pregnant. Dhiiraadhaan you are pregnant yoo jetteen isaanis false positive. Namni akkamitti dhiira ta'e ulfaa'uu danda'a kan jedhu type 1 error jennaanis immoo isheen sun yoo ilaaltu ulfoodha. Garuu maal jechaa jirti? You are not what? Pregnant. Such type of error is known as false negative. So it is type 2 error. So we have to take care during hypothesis testing and accepting the hypothesis to avoid what type 1 and type 2 error jechuudha karaa biraatiin jechuudha. Inni itti aanu check type of test now. One tail test jedhamu two tail test kan jedhu beekuu barbaachisaadha. Fakkeenyaaf if the inequality sign in the alternative hypothesis are is equal to or different from, this implies two tail test now. Equal to greater than or less than kan jedhu yoo ta'e immoo one tail test na. Yes, greater than or equal to mallattoon kun jira taanaan one tail test dha. Mallattoon kun jira taanaan immoo two tail test dha. Kanaafi testii kan fayyadamna kan jedhu check gochuun step sadaffaa irratti kan nu ilaallatu testii fayyadamuu keenya dura jechuudha. Fakkeenyaaf if we have a null hypothesis equal to this one against alternative hypothesis this, and this is a two tail test because this sign indicate two tail test. Now alpha value keenya immoo 5% divided into maaliif two tail test ta'e taanaani ishee kana bakka lamatti qoodna alpha over 2 jechuudha. That is 2.5% jechuudha. Then you have to determine the critical t value from table. Critical t value from table at alpha 1 over 2 jechuudha. Look, obtain t value at t critical at alpha over 2 and the n minus 2 degree of freedom for two tail test. Alpha over 2 kan jenneen fi two tail test dha waan ta'eef maaliif alternative hypothesis keenya mallattoon as jirtu tuni different from waan ta'eef jechuudha. Now compute t calculated. T kan erga calculate goonee booda t calculated greater than t look t of table is greater than critical t yoo kan ta'e null hypothesis keenya maal goona reject goone, alternative hypothesis keenya maal goona accept goone. Gaafsan b beta it is what significant, statistically significant jenna. If t calculated is less than t critical, you have to accept null hypothesis and reject alternative hypothesis. Conclusion keenya b is what statistically insignificant. Kana jechuun x and y keenya hariiroo hin qaban jechuudha. Hariiroo hin qaban jechuudha. Naaf example biraas nu kennameera. Fakkeenyaaf n keenya digdama. C maybe this one is a cost consumption or consumption function keenya nu kennameera. 100 plus 0.70 plus e. Now here 75.5 and 0.21 nu kennameera. This implies beta 1 nu kennameera jechuudha karaa biraatiin. So beta 1 nu kenname taanaan degree of freedom isaanii barbaadne keenya calculate gochuu ni dandeenya. So the value of the bracket are standard error. So we test the null hypothesis against the alternative hypothesis using 5 level of significance. Therefore, key value for the test statics is simply b over standard error. Bin keenya mo 0.7 ta'e nu kennameera. Beta hattin keenya mo ishee kana akka ta'e beekna. Shin kun slope dha waan ta'eef asitti beta value kanaaf now 3.3 arganneerra jechuudha. 3.3 arganneerra. Since the alternative hypothesis sign is what? Inequality two-tailed test dha. Alpha value keenya 0.05 bakka lamatti qoonna jechuudha. That is 0.05. To obtain the critical value of this, the degree of freedom is 18 because degree of freedom in Kenya 80 on the n minus 2 n in Kenya digdama sila tureefi digdama irrisu lama kudha saddeet sila ta'eefi jechuudha no. From that T table at 0.05, the level of significance at 80 degree of freedom is 2.1. Kana table irraa arganne alpha value in Kenya 0.0 ta'e degree of freedom in Kenya kudha saddeet ta'e taanaan table value irratti lama tuqaa tokko arganna. Kanaaf t keenya 3.3, t sin keenya mo 2.1. Now t is greater than tc. This implies beta hat is statistically significant. Beta hat is statistically significant jechuu ni dandeenya jechuudha. Inni sadaffaan method of estimation or statistical estimation keenya sadaffaan immoo confidence interval. So the rejection of the null hypothesis doesn't mean that our estimate alpha and the beta is the correct estimate of the true population parameter alpha and the beta. It implies or simply mean that our estimate comes from symbol drawn from the population whose parameter beta is what? Different from 0. So in order to define how close the estimate to the true parameter, we must construct confidence interval for the true parameter. In other words, we must establish limiting value around the estimate with it, which is the true parameter is expected to lay within the certain degree of freedom or degree of confidence. So in this respect, we say that the given probability of population parameter would be within the defined confidence interval. So, for example, if it is two-tailed test, alpha is the level of significance, the probability of obtaining specific t-value is a tc or tc at alpha over 2 n minus 2 degree of freedom. So the probability of obtaining is simply beta hat minus beta over standard error of beta degree of freedom in minus 2, which can be given in this formula. Or this implies at the end of the day kana jechuun immoo gara tokkotti deemu waan ta'eef tokko hir'isuu alpha jennee murteessuu ni dandeenya jechuudha confidence intervaliitiin. So in the confidence level in the decision ruling keenya maal ta'e the hypothesis value beta in the null hypothesis within the confidence interval, accept null hypothesis and reject alternative. Implication in Isamaini beta is statistically significant, while if the hypothesis value b is in the null hypothesis outside the limit, reject null hypothesis and accept alternative hypothesis indicate beta is what? Significant. Statistically significant. Fakkeenyaaf now suppose we have 20 sampling keenya digdama. Again the equation y is given by regression line is equal to 128.5 plus 2.88x plus e or error term. Now here is beta value, here is the slope. So now the value in the bracket are standard error. This one is standard error. So construct 95 confidence interval for slope parameter. Inni lammaffaa test significance of the slope parameter using confidence interval. Confidence interval keenya 95%. Sanaaf kan gochuudhaaf maal gochuu qabna? The limit within which true beta lays in 95 confidence interval is equal to beta hat plus standard error of beta at tc or t critical. So beta hat immoo already 2.8 nu kennameera, standard error in keenyas nu kennameera. tc immoo 0.025 maaliif akkas jennee now 95 nu kennameera. That is 0.05 jechuudha. Alpha value two-tailed test waan ta'eef bakka lamatti qoodne jechuudha. Degree of freedom 18 kanaaf value kun immoo reefu table irraa lama tuqaa takka argannee turre. Now you have to beta hat plus standard error times tc which implies 2.88 plus or minus 2.1 into 0.05, which mean this one. Therefore, our confidence interval amma jiddu kana jechuudha. Tokko tuqaa 0.9 fi 4 tuqaa 6.7 maal jechuudha? Lama hir'isu, lama tuqaa 8.8 hir'isu, tokko tuqaa 7.9 isa kan arganna. Lama tuqaa 8.8 da'u, tokko tuqaa 7.9 immoo 4 tuqaa kan arganna jechuudha. Kanaaf amma limitii keenya confidence interval keenya arganneerra. Therefore, the beta value in the null hypothesis is 0, which implies that it is outside of the confidence interval. Therefore, beta is at significant. Maal jechuu isaati? Beta value in the null hypothesis keenya 0 sila ta'ee fi range nuti lakkoofsa yookaan confidence interval keenya kana ala waan ta'ee fi confidence interval keenya ala ta'e taanaan immoo beta maal jenneerra statistically significance jenneerra waan ta'eef decision rule keenya fayyadamne we say that beta is statistically significance. Beta is statistically significance. So finally we have reporting as a result of regression analysis. Our researcher jenne boda ngidi result kenya by using regression analysis report gona. So that's regression line can be interpreted so as to give some econometric decision. Econometric decision iragauda reporting regression analysis is very important jechuudha. So for now this is the end. Kana caalaa bal'isuu ni dandeenya, but garmalee bal'achaa deema waan ta'eef at least paartii 3 kana yoo ilaalle nu gaha. Kanaaf thank you very much for your nice attention.